Good morning to everyone. Today we'll discuss about compiler data structures. So first one is literal table. So it stores constants and strings used in a program. Data in literal table applies globally to a program. Deletions are not necessary. Next one, tokens. Tokens are it takes a stream of characters are and identifies tokens from the lexemes. Tokens are used to represent low-level program units such as identifiers such as some value and x, numerical values such as 1, 2, 3, uh, operators such as plus, star, ampersand, less than or equals to and percentage. Keywords such as if, else, and return. Many other language symbols. Eliminates comments and redundant white spaces. Next one is code optimizer for intermediate code generator. The code optimizer optimizes the code produced by the intermediate code generator in the terms of time and space. So see, this is the example. So multiplication of two identifiers and stores in a temporary value. So add temporary two values are add and stores in a temporary value. Next one is intermediate code generation. So a compiler may produce an explicit intermediate codes representing the source program. So these intermediate codes are generally machine architecture dependent. So but the level of intermediate codes is close to the level of machine codes. So for example, new value equals to old value into factor plus 1. Identification 1 into identification 2 into ID 3 plus 1. So multiplication of ID 2, ID 3 temporary 1. So addition and move. So in this ID 1 values move to temporary 2 values. Classes of tokens. There are many ways we would represent the tokens of a programming language. One possibility is to use a two tuple of the form token class value. For example, consider the token class identifier. The identifier's sum and value may be represented as ident sum and ident value respectively. Semantic analysis. Some optimization may be done during this phase. Source code optimization. Example, constant folding x equals to 2 plus 4 can be optimized to x equals to 6. Intermediate code optimization. Temp equals to 5. A of index equals to temp can be optimized to a of index equals to 5. Lexical analysis. So the job of the lexical analyzer or scanner is to read the source program one character at a time and produce as output a stream of tokens. The tokens produced by the scanner serve as input to the next phase. The parser. Thus, the lexical analyzer job is to translate the source program into a form more connective and recognition by the parser. What is a compiler? A compiler is a language translator that takes as input a program written in a high level language and produces an equivalent program in a low level language. For example, a compiler may translate a C++ program into an executable program running on a processor. Compiler data structures, parse tree or syntax tree, a linked structure built by the parser with information added by the semantic analyzer. Each node is a record whose fields contain information about the syntactic construct which the node represents. Nodes may be represented in various ways. A C structure, Pascal or ADA variant record, a C++ or Java class. The scanner in action. So if of x less than y mean equals to x, the scanner scan all values. So a parse tree. So consider for example if statement. If statement have both close parentheses and open parentheses. In between we have expression and statements and assignments operators also. So introduction to compiler design. Compiler data structures. Intermediate code could be kept in an array, temporary file, or linked list. Representations include P code and three address code. So parsing techniques. So depending on how the parse tree is created, there are different parsing techniques. These parsing techniques are categorized into two groups: top-down parsing, bottom-up parsing. Top-down parsing Construction of the parse tree starts at the root and proceeds towards the leaves. Efficient top-down parses can be easily constructed by hand. So recursive predictive parsing, non-recursive predictive parsing, LR parsing, bottom parsing. So construction of the parse tree starts at the leaves and proceeds towards the root. Normally efficient bottom up parsers are created with the help of some software tools. Bottom parsing is also known as shift reduce parsing. So operator precedence parsing, simple, respective, easy to implement. LR parsing, much general form of shift reducing parsing. LR parsing, SLR, LALR, code generation. So it takes intermediate code and produce object code. So syntax analysis. The syntax of a language is defined by using a context-free grammar. A CFG is uses BNF rules to describe the syntax. So this is the phases of compilation. So we have five phases in the compilation. Lexical phase analysis, also called as scanning. Syntax analysis, also called as parsing. Syntax analysis, optimization. Not in this course. So code generation. So we will discuss about these phases in next class. Thank you.